Thanks for tuning in to today's conversation about COVID-19 and separating fact from fiction. I'm thrilled to have Dr. Lindsey Leininger joining me today. Dr. Leininger is a public health scientist with expertise in data-driven health policy. She has spent much of the past year on the front lines of COVID-19 science communication. As part of an all-female team of nerdy girl scientists, Dr. Leininger runs the COVID-19 educational campaign called Dear Pandemic on social media, one of my favorite resources. And that's just what she does for fun. Dr. Leininger is also on the faculty at the Tuck School of Business at Dartmouth College, where she teaches current and future healthcare leaders how to make sense of medical data. Today's conversation is part one of a two-part conversation. In this episode, we share practical advice for navigating the seas of information and misinformation that we're all drowning in right now. In part two, we explore vaccine hesitancy, anti-vax movement, and COVID-19 denial. Let's dig in. Welcome to Get Real Health. I'm your host, Dr. Chana Davis. This show cuts through the noise to give you science-based insights from real experts so that you can make smart, healthy choices. Welcome to the show, Dr. Leininger. Thank you so much for being here.
Chana, thanks for having me.
May I call you Lindsey?
Oh, please do.
Okay. So let's jump in with what has it been like to be on the front lines of COVID-19 science communication? Can you tell us a little bit about Dear Pandemic and what you've been doing through that organization? Or I don't know, organization is the right word. Platform, maybe?
Platform, that's great, right. So we are a public education campaign that provides timely, trustworthy, and curated information about the pandemic. We've been at this for a little over a year now. Our home base is social media. We have, I think I last checked, about 120,000 followers, about 3/4 of which are on Facebook. So we're really native to the Facebook platform. Mm-hmm. And we have now answered over 900 questions on all things in the pandemic, from do I need to wipe down my groceries to the immunology behind vaccination technology. Mm-hmm. So it's been a pretty wild ride. But the best part of the work has been being part of our all-female team of quote-unquote nerdy girl scientists. There are a dozen of us who are founding members, and we've now been able to source information from almost 24 contributors. So that's been really special to meet all these amazing women across all sorts of scientific disciplines.
Yeah, that's wonderful that you're really showcasing women in science, especially now. I've been seeing a lot of articles on how women in science are suffering and being, fewer submissions from women and all sorts of things indicating maybe a greater effect of the pandemic on their ability to put work out.
Yeah, it really breaks my heart, honestly. I mean, if you think of all of the human capital that is frankly just being scarred based on this pandemic for women, it's a tragedy. And which is why part of my why for doing this work is both helping keep the public informed through a pandemic, but also amplifying women in science and STEM fields. So I am very intentionally trying to be a cheerleader and a good standard bearer for all of us right now. And Chana, just like you, right? I feel like we have a very similar mission, which is neat.
Definitely. So I want to share with our audience start with some very concrete pieces of information. So maybe you can just share some of the most common or most common questions and very popular posts that have really been taken off over the last year out of those 900 some questions that you have answered.
So I would say they're in three categories, and one is just explaining the scientific headlines. So for example, we wrote one recently on why you can or cannot compare efficacy of vaccines, one from the other. So that type of flavor has been very popular. Then I would say the second flavor that's really been popular have been myth busting, really, for lack of a better word. So, I think we keep hearing, COVID is much worse than the flu, but there's this myth that just is like a hydra that we just keeps coming up in the narrative that is no worse than the flu. So every time we write on that, that's pretty popular. And then we have a third form of posts that is my particular beat, if you will, which is the information hygiene beat is what we call it. So in this era of just kind of information overwhelm across digital places and spaces, we're really trying to help people be better consumers of information that comes across their feed. So again, an example of this is a post I wrote last week, or maybe it was 2 weeks ago at this point. What is time in a pandemic? But it was evidence-based tips on how to talk to a conspiracy theorist.
Yes.
And this week, tomorrow, I'm going to be writing a post on how to have a conversation with a loved one who's vaccine hesitant using evidence-based tips.
Okay, well, I'm not going to let you share that right here because I want to do that in part 2, and we're going to have a 2-part conversation. So don't give the answer to that one yet, but that's awesome because I do think I share the same mission of I've been using the term scientific literacy and media literacy to help people really be more critical consumers of the information that they're receiving.
Chana, that's amazing. And it makes me like my heart just kind of did a beat hearing you say that, because I think in this new day and age of the infosphere that we're living in right now with social media and just really fractured trust and people going to all sorts of different places to get their sources, that we really have to marry scientific literacy with digital literacy and information literacy. So it just, being in conversation with someone who also believes that work at the intersection is really what's crucial to move us forward in science communication just makes me really happy. Yeah.
So maybe we could just shift gears then to talking about information literacy, but without getting onto the anti-vax topic yet. But I'm trying to think about what are some of the sort of fundamental knowledge gaps that we can help fill for people that allow them to, I guess I'm sort of thinking of this, digesting this question real time, but I'm kind of thinking about this in 2 ways. One is sort of concrete biological foundations, like basic concepts about how biology works that people can probably pretty easily grasp and don't need to go back to school to get, but it can still serve them really well about, for example, how infectious diseases work, right? Having a model for how these things work. And the second is being more discerning about a piece of information that comes your way and having a way to sort of pressure test the credibility of that. Do you see things through that same kind of framework, or are there another category, I guess, of knowledge gap and skills and that you would want to bring to the discussion?
What a great question. So I think of these as a triangle, and the ones that you mentioned are 2 legs of that triangle. And the third one that I add in there, because it's my personal passion, is data literacy. So I think that there's like the basic biological literacy, which, I love, you're a basic scientist. So I love that that's, kind of the leg that makes a lot of sense for you to center in. And then also the information hygiene or the information literacy beat, basically like teaching people what the standards of ethical journalism and reporting are, because everyone's a journalist these days. And then the third leg of the triangle for me is really coaching people around data literacy.
Yeah. So maybe we can just talk a little bit about some of your, I think, most useful nuggets within each of those categories then. And I can't help but share a little bit myself when we get to the biological one, but I'll let you go first on the data literacy information, sort of how, I guess, maybe just interpreting how data are presented and how do people, how can people get started in boosting that axis of their literacy?
So I am actually going to completely cede the biological literacy and scientific literacy to you, because I don't do that. So we joke on our team, like, I'm not one of the nerdy girls that does the inside the body stuff. Like, I can tell you about populations. I can tell you how data-driven health policy is made. I don't do inside the body stuff. So that's why it's good. That's why I need to partner with people like you, Chana. But I will tell you, the data literacy is something that's been with me my entire career. So prior to doing public-facing work, promoting data literacy among lay audiences, I spent a dozen years supporting health policymakers, helping them make sense of medical data and integrate it into data-driven health policy. So I lean really heavily on frameworks and simple heuristics. I'll give you an example, because sometimes that's the easiest way to articulate. When there's a new clinical trial result that comes out, I use what's called the 3 C's framework: comparative control, chance, and context. So that's how scientists vet a study. We think, how well controlled is this? Is there a credible comparison group? We think, has it reduced the role of chance, which is where statistics and statistical inference comes into play? And then we think about how generalizable is this outside the context of this study. So we always, when there's a new trial result, we 3Cs it and we write about it on our platform. So that's an example of data literacy types of initiatives that I'm particularly committed to. The information hygiene beat also is just a personal, it's a personal mission that really came with the pandemic and is new to me. So I'm trying to learn as much as I can about journalism, frankly, like the 6 ways to snuff out scientific subterfuge, right? The tips that journalists use and pass among each other in order to vet this information and translate it for lay audiences. So I write a lot about great information that comes out from organizations like the News Literacy Project, for example. There's lots of great kind of fact-checking frameworks and ways that we can help our readers.
Let's go. I love that 3C framework. So it might be useful to actually give some concrete examples where people are failing to apply that, and how applying that gives a different, helps you sort of chill a bit, right? So the two examples that come to mind for me are when we started to see these Bell's palsy cases popping up early on. And another one is recently someone was just telling me they heard about people that, ended up hospitalized after a vaccine, and there wasn't, got vaccinated and somehow still ended up in the hospital. And, I'm thinking automatically, well, what's the denominator? But like thinking like examples like that. So what are some ones where something, if you don't have the right context, it gets misinterpreted that we've seen throughout?
So one of my favorites is animal studies. So a lot of times we'll read headlines, and this precedes the pandemic, that's like, ooh, there's a trial that shows that this type of variant can't be beat by our current vaccines. And it was basically a test tube in a lab. And yes, the experiment was well controlled. They randomized different exposures in terms of the test tubes. And yes, it was statistically appropriate in terms of sample sizes. But, bench to bedside is a big leap on that 3rd C of context. Yeah. And that's one that we scientists just innately know to be like, wait a minute. This doesn't mean necessarily anything in the real world. So that's one example. I think the context C
can I see that one?
Is
that
very
one bleeds
important.
over into biological literacy as well, because it's understanding that, having worked in drug development, that things don't translate from, cell lines to animal models to human. There's a huge gulf in what we see across different platforms. And so I think that's both, and understanding that biological concept.
And Chana, what's the fun phrase here? Like monkeys lie and mice exaggerate. I'm probably not getting that right.
I don't know that phrase. I'll have to look it up.
Sanjay Gupta always talks about it. Okay. Why animal models don't generalize. It's funny.
So sorry, I co-opted you were saying that an example there would be, such and such variant doesn't have good efficacy in animal models, therefore it probably won't in humans.
Exactly. Or like we shot an unbelievable viral dose of the SARS-CoV-2 virus into a petri dish.
Right.
And like, lo and behold, it would cause this awful thing. These are the sorts of like scary headlines that, like you said, I think helping people chill a little bit is really part of our mission, just like yours.
Yeah. Well, when I also discuss a lot in the, on my social media and so on about nutrition fears, and parents are so often told to worry about X, Y, and Z in their food, and they're poisoning their children. And so for me, one of the most basic fundamental concepts that serves people well is dose makes the poison, and that everything is how much did you get relative to what's considered a safe threshold, and that anything can be a poison at a dose. So I think that's a very important scientific foundation.
Oh my gosh, Chana, that's my new favorite phrase. Dose makes the poison. I hadn't heard that one.
Yes.
I love it. It's so true. Yes. I mean, and we're taught, those of us trained in the population sciences, like epidemiology, we're taught about dose response as a key criteria to pinpoint causal relationships. So again, dose makes the poison, like dose makes the impact.
Yes, exactly. So I feel like we're rambling a bit, but so we had first example being, not understanding whether we're in the right system and whether a result is relevant. And I think anytime you see a headline that's not in humans, I just always tell people take it with a grain of salt. That's true for COVID. That's true of cancer. That aspartame and rats or whatever it is. It's those sorts of studies. It's all about, is it the right system and is it at a relevant dose? That's and then the control thing, is that where you were heading next? Sorry, the next C
Yes.
that you were going to talk about?
So we talk a lot about the difference between randomized controlled trials and non-randomized observational studies. So one, is there a comparison group is the first question. And two, how credible is the comparison? How apples to apples, if you will, is the comparison across the two groups, the treatment arm and the comparison arm? And we always talk a little bit about how that C is the holy grail of science. It's the hardest one. It's why we run the randomized controlled trials. It's the sort of standard bearer when it comes to regulatory science, is that particular C. It's a tough nut to crack outside of random assignment.
And I think that's where the Bell's palsy example comes in. I believe it was, I forget which one, but one of the vaccine trials had some Bell's palsy cases in the vaccinated group and not in the control group, where they had more of them in one group than the other. But getting to the C of chance, it wasn't clear whether the control group was having lower incidence than you might expect by chance versus the actual vaccine group was having a higher incidence than you expect by chance.
We talk a lot about base rates, just like you articulated really nicely. Like, I feel like base rates is a beat for us. Like, whenever you see these scary headlines about Bell's palsy or even blood clots after viral vector vaccines, what's the base rate, right? And we also talk about this when it comes to deaths, like excess mortality, right? Deaths above normal. I think those of us who are trained as scientists, and Chana, whether it's you as a bench scientist or me as a population scientist, we have base rates baked into ourselves at this point, right? We're just so attuned to it. And it's something that we can really help make more salient for the public.
Yeah. I remember being, having a bit of an aha when I was told that it's pretty common in vaccine trials to see autoimmune conditions developing at some rate, and really it was because of just greater scrutiny, and that because they're done in a population where these things wouldn't normally be screened for and caught, that if you just start screening, you catch more things. So I actually worked in cancer early detection as well, so I'm always thinking about the detection, the sort of effect of additional screening on additional detection.
Oh, Chana, we have a lot to talk about, not in this, but maybe in a different one. I teach over-screening in my healthcare analytics class for MBAs because, again, this is tricky in our healthcare system. There is too much screening, and that is a hard concept for, I think, lay audiences to understand, because early detection, that's great, that's better, of course we want that. Well, there can be damage done too, and that's a nuance that bears repeating. And actually, Chana, I'll tell you a funny anecdote. The screening and the over-screening, that is consistently every year the favorite topic of my MBA students in my health analytics class. Yeah.
Might have to do a podcast.
False positives, false negatives, the impact of base rates on whether or not the false positive or false negative rates more likely to be higher. Exactly. That is hands down every year their favorite topic.
That's fascinating. So we're missing the context. So can you give some times when maybe context hasn't been appropriately applied throughout the pandemic and led to erroneous or concerns?
So I think the one that's stickiest in my mind right now, because I've just been doing this work over and over on one-on-one conversations, again, is this comparison of the efficacy of J&J vaccines against Pfizer and Moderna. So the headline numbers are quite different, but they were trialed in very different contexts. And so my understanding, although this is your bailiwick, so I defer to you, is that all these vaccines were built off of the original sequencing of the wild type or original coronavirus. And J&J was trialed in a context where variants were more prevalent and where in South America and other countries, South Africa or other countries, we think that that might have some impacts on the efficacy rates. So I think context is key. And this is the example I like. Wait, not apples to apples. Pfizer and Moderna got a good start in an earlier time period.
Yeah.
J&J didn't.
Yeah, I think that's great. And it's very relevant actually right here in Vancouver right now. I don't know if you're aware, but we were just told that people over 40 are now eligible for the AstraZeneca vaccine. And if you look at any efficacy graph, it's like, oh, there's the worst one over there. And people are like, should I take that one? It doesn't look very good. And basically we're being told that if we wait a few months, we'll probably get like Pfizer or Moderna through the age bracket system. But if we sign up now, pharmacies are giving AZ, and everyone's like, do I take this, second-rate vaccine, or do I wait for the better one? And I've been trying to communicate just amongst friends that it is not an apples-to-apples comparison, and it's actually a moving target, because as the strain landscape changes, the efficacy of different vaccines changes against the relative performance of different vaccines will change.
Absolutely. And so along those lines, we're getting lots of questions about boosters, right? And because our vaccines are going to have to keep up to date. So it's very hard, because those initial headline numbers are super sticky in our brain.
Yes.
Like when people think Pfizer, they think 95%. When they see J&J, they think 66%. And that's what's stuck. And I know AZ is sort of similar, right? It's in your context, in the European context. And it is really hard to unstick that in people's brains. And that's where you and I come in, and we just have it. That's like a hard, slow series of conversations. Right?
You're making me think of actually a fourth C that I've been kind of trumpeting recently, which is confidence intervals.
That goes under chance. I love confidence intervals.
There we go. Okay. So can you elaborate on that? And I think with the vaccine efficacies, that people aren't talking enough about confidence intervals.
That's right. I completely agree with that. We can never completely rule out the play of chance as statisticians. And although larger sample sizes help us, and although statistical inference measures like p-values or confidence intervals, basically margins of error, really are our best measures of chance. And so it's just like political polling, right? When we talk about polls and they'll say, oh no, the margin of error overlaps, it's a dead heat. Well, in science, it's similar, right? And that's that sea of chance, is statistical precision. One, how we characterize it, and two, how we kind of battle against it, which is larger sample sizes and replication across multiple different studies. Yeah.
What I was trying to tell a friend the other day was that even though these trials have tens of thousands of people, the case numbers are much smaller. So you're comparing, 100 cases versus 8. And what if it was 9? What if it was 7? That would change the answer significantly. So you should be trying to dig into what's the range of estimates that we have for what the performance is, not like the point estimate.
I could not agree more. And this is why, kind of on an analogous topic, I really like to anchor people in what risk communicators call natural frequencies. So just like you did there, right? Instead of being like, it's 95% effective, being like with the blood clots, 6 women ages 18 to 48 have developed these blood clots. Now I think it might be up to 8 here in the US. There have been 7 million J&J vaccines given in the US. So describing this in natural frequencies like you just did, I think is so important to help people's brains kind of let the numbers settle in a way that's not like 95% versus 66%.
Yes. Yes. I don't want to put you on the spot, but if you happen to know off the top of your head, 6 or 7 out of 7 million vaccines, but if you narrow that denominator to the age group of those women, do you have a sense of if it starts?
Well, it's still super rare, right? Yeah. And I mean, again, you're the inside the body scientist. I'm not, so I'm going to be out over my skis here a little bit more than I'm comfortable. But my understanding is the scientists are still conceptualizing the model that why it might only be women and not men. So I think bickering, trying to characterize a denominator is something that we do as scientists. I mean, it's literally our job, right? But I think the wonderful message that I'm trying to get out is that whatever denominator you choose, it's still a really, really, really low risk.
Yeah, I agree. So I feel like we've taken up a lot of the time that I wanted here. We only got to one of the pillars, really. We've been leaking into the others. I think just to throw this out there from the sort of biological pillar, I think the one that my husband's also a biologist, and we were talking about this early on, the one that we felt was missing for many people was just having a mental model of how a virus spreads. And
yes.
And that there multiple steps have to happen. So when you're trying to think how risky is such and such event, you need to think how does that event, can all these steps happen? So the person A needs to spew the virus out. The virus needs to somehow leap from the person A through an orifice in person B. And it's not just one viral particle. It has to be, there's an infectious, dose, and it's not usually one, right? So there has to be, right. Hundreds or thousands of viral particles need to make their way from person A to person B and then enter the cells within person B that are actually susceptible to viral infection. So even that very basic framework, I think a lot of people didn't have that. It was just like a black box. And so I think
totally.
One of the things that I found useful was there's a random Google doc from some aerosol scientists that they help speak of it in terms of, secondhand smoke and thinking of that kind of, if someone's face to face and you think you would be absorbing a lot of their secondhand smoke, that's probably a context in which you could be absorbing a lot of their virus. But the difference between having a conversation face to face with someone for an hour at a table at a coffee shop, outdoors or indoors, versus going for a walk, the amount of smoke you're going to get from that person is different, and you can kind of use that mental model to conceptualize it.
It's so true. I mean, and just what you did right there, I feel like is very effective science communication. So helping people understand the model, right? You've already introduced this great catchy phrase, dose makes the poison. And I think that totally, relates here. And then you anchor it to something that is relevant to them. Like, I am not a biologist, but I understand secondhand smoke, right? So like you've pegged it to something that's relatable. And so,
right.
Mike Osterholm talks about the forest fire analogy in terms of like outbreaks. And I really like that. And I really like how you've sort of adopted the secondhand smoke analogy to help people get that mental model. Because you're right, knowledge is power. And once you feel a little more self-efficacy or control over understanding how the virus spreads, I feel like that makes people feel more chill. Back to your initial comment.
Yeah. I mean, especially early on the pandemic, people were just freaked out just walking past someone on the street. And I'm thinking, how on earth is virus going to jump from them into me just for walking past them? It's inconceivable. I mean, if we stop and do this to each other, but I just, so I think a basic model goes a long way, and that's one that I hope people are emerging with. I also think, and you can probably speak to this as well, that I think the pandemic has been great for teaching people that science is an evolving process, and that the fact that science evolves doesn't mean you shouldn't trust it. It actually means you should trust it more as recommendations change. So can you speak to that?
Well, that's a topic near and dear to my heart, because that's one of my mantras. And in fact, the most popular post I've written at Dear Pandemic was about this concept that science is a method, not a fixed set of facts. It's about habits of mind. It's about trusting scientists who do change their mind and being leery of ones who don't. So I've been able to talk about this now. So like I said, that was my most popular post I've written on DP, not the other, not other team members, but mine personally. And it's something that I've been able to take on TV, that I've been able to take to newspapers. The science is a method, not a fixed set of facts. And so that's kind of my one mantra. And I love that you share it too, because I think the more of us out there who are scientists, who are socializing people to what science is and isn't, is really going to help build trust, frankly.
Exactly. So maybe we should wrap up this conversation here, because I want to have a second conversation about vaccine hesitancy and COVID denial, which is very much related, but it's sort of self-contained in a way. So to wrap up today, are there any resources that you recommend for those looking to boost their scientific literacy and information literacy?
So I mentioned the News Literacy Project. It is an A+ resource, and it is great for everyone from grade schoolers to adults. They have educational materials. Similarly, Pointer, it's a journalism nonprofit, probably the preeminent journalism nonprofit, has a lot of great resources, again, for educators, for kids, for scientists. I love them. They're truly terrific. So those are my two kind of information literacy go-tos. I think for basic science literacy, we are so lucky these days that there's so many options on Coursera. So you can go and take a Bio 101 course or a Stats 101 course. I think in terms of, we work really hard to talk on the data literacy beat, so I'm biased, and
I loved your pandemic. I'll definitely.
Oh, thank you. And I love you on the nutrition beat, right? Like, I feel like you have the nutrition, like, I really appreciate that as someone who just gets really kind of triggered by junk science on the nutrition front. So I want to give a shout out to your work and our work. And then I also, there's just a lot of good, relatable, credible science messengers that have come out of this pandemic. And I hope that we continue, frankly, to diffuse across the information sphere, because the more of us out there doing this, I think the better. Good news sources. I always like anything that the AP pushes out. I trust Reuters a lot, and I think that NPR's Goats and Soda has actually been a really good, accessible, and oftentimes even fun, faithful reporter throughout the pandemic. So those are my go-tos.
And on the Dear Pandemic page, I believe you have a list of some recommended sources that you guys use. Am I right?
That's right. Yes, we do. And I think, that's a little dated at this point. What we need to do, actually, we have a nerdy neighborhood that we've established. It's a coalition of science communicators, primarily female. I hope you'll join us. We have a Slack channel. I would love to invite you and have you be part of it. And we are kind of each other's own trusted resources, and we amplify each other. We are clinicians, we are nurses, we are in Chicago, we are in Canada. Actually, there's a Toronto woman. So we have each other and each other's channels. And as a collective, we speak to almost 500,000 people on social media.
Oh, that's great. Well, thank you for sharing all these great resources and helping people take a step forward towards separating fact from fiction.